Okay, this lesson is on solving systems of equations by graphing. You've done some of this before, and so we're going to go over the warm-up real quickly, and that's just reviewing what you already know about graphing equations of lines. And so we're just going to go over that. So y equals -4. Remember, if there's only one variable, that means it goes through the y-axis at -4. So you're going to go through the y-axis at -4. That's what that graph looks like. Okay, number 2. This is my slope. This is my y-intercept. So I'm going to start at 3, my y-intercept. My slope is -1/2, so I'm going to go down 1 and over 2. Down 1 over 2. I could also go up 1 and backwards 2, but that's going to make my line. So this is reviewing what we've done in earlier lessons where we graphed equations of lines. So we're going to be doing a lot of that, so it's good to be practicing this. This is y equals 2/3 x plus 0, so that means I'm going to be starting at 0. I'm going to go up 2 and over 3. I can go down 2 and backwards 3 because down 2 and then backwards 3 is the same thing as positive 2/3. So that's going to be my equation line there. Okay. Number 4. My slope is -1 because that's -1x plus 4. So I'm going to be starting at 4. I'm going to go down 1 and over 1. So if you didn't remember how to do that, that's how you do it. So make sure that you put that together like that. Okay, number 5, x equals 4. So again, if we only have one variable, it's going to go through the x-axis at 4. So it's going to be going like this. Okay, so that's our vertical line. That's the one that has the slope that's undefined. But that's what that equation is going to look like on a graph. Okay, number 6, my slope is 3. That's 3 over 1. My y-intercept is -5. So I'm going to start down here at -5. I'm going to go up 3 and over 1. So if you feel like you need to practice doing this more, then practice doing it more. But this is going to be something that's going to depend that you know what you're doing when you're graphing equations of lines. Okay, the last two problems on the warm-up were if you have an equation like 4x plus 3y equals -12, let's solve that for y. So that means you have to get y alone. So we're going to get rid of the 4x, so kind of like the idea where you, like in my classes I said, if you are peeling an onion, this is the center of your onion, you're going to go outside layer first. And so, or if you talk about putting your finger over that variable y that you're solving for, what do you get rid of? Well, first you have to get rid of the outside piece. Okay, so let me erase that. Okay, so we're going to subtract the 4x, and then this is the other side, so I'm going to subtract it over here. Please remember, these are not like terms, so you're going to have 3y equals -4x minus 12. You cannot do anything else with that because they're not like terms. So don't do 12 minus 4 or -12 minus 4. That's not going to work. The next thing that you're going to do here is you are going to divide by 3, and everything has to be divided by 3. So you're going to have some situations like this where it comes up and you're going to have to solve for one of these variables, and most often y with a linear equation. And you have to make sure that you are dividing everything through. This is the same equation as this one, but this one is in slope-intercept form. And so the reason why we care about getting it like that is because now that it's like that, I know my slope is -4/3. I know my y-intercept is -4, so I can graph it. Okay, let's look at number 8. If we're going to solve for y, so again, here's y. So I'm going to get rid of the -28 first. So I'm going to add 28 because it says -28, so I'm going to add 28. Again, these are not like terms. So I'm going to have 4y equals 2x plus 28. I cannot do anything else with that. Next, I'm going to get y by itself by dividing by 4. So everything has to be divided by 4, not just one of the pieces, all of it. 2 over 4, if you reduce that fraction, that's going to be 1/2 x, and 28 divided by 4 is 7. So that equation is the same as this original one. This one is in slope-intercept form. And again, the reason why we care about that is because if it's in slope-intercept form, then we know this is the slope and this is the y-intercept, so I could graph it. I'm going to start at 7. I'm going to go up 1 and over 2, up 1 and over 2, so my graph is going to look like that. And that's why I want to get it in that form. Okay, so for the lesson, we're going to start out by doing that same thing. So let's take number 1. We're going to solve this for y, and then we are going to graph it. So here's y. I'm going to get rid of the negative 3x first. So I'm going to add 3x. So write that down. You have to do it on both sides. So I'm left with y equals, and then not like terms. Not like terms. So it's going to be 3x minus 2. Now, could you do negative 2 plus 3x? Yes, you could, but then it's not in the form that we're used to seeing it so that we can graph it easier. If it's 3x minus 2, then I know this is my slope, so 3 over 1 is my slope, and negative 2 is my y-intercept. So when I go to graph it, I start at negative 2, and I go up 3 and over 1, up 3 over 1. Then we connect our points with a straight edge, and that's what that equation looks like. If we had just used this equation that we had at the beginning, if we'd have just had that, you can't tell from looking at that my slope is positive 3 over 1. You can't necessarily tell what my y-intercept is. So it's very important that you can put these equations in that form. Okay, number 2, we're going to do the same thing. So we've got y, we're going to solve it for y. So what's going to be outside of that? It's going to be the 3x. That's what we're going to get rid of first. So I'm going to subtract 3x. Okay, watch your like terms. We're going to have 2y equals, and then over here, not like terms, so negative 3x plus 4. So I'm trying to get this in y equals mx plus b form. So I've got the x and then the b, but I still have this 2 in front of the y, so I'm going to get rid of it. 2 divided by 2 is 1, so I just have 1y. I'm going to divide the other side, everything, by 2. You have to remember to get everything, not just the parts that are convenient, but all of it. Okay, now that I have that, I can graph this by saying positive 2 is my y-intercept, and then down 3 over 2, down 3 over 2. And that's my equation that I'm going to be graphing. So connect the points, and that's the picture of that equation. So again, we do that because if you looked at this equation, would you have known that the slope was negative 3 over 2? Probably not. Okay, let's go to number 3. Okay, this one is different because if you'll notice, this is an exponential equation. So we've dealt with exponential equations before, and we've graphed them. We've always made a table first. And you can certainly do that. If you get stuck and you don't know what to do, make a table. That's the answer. If you're stuck and you don't know how else to graph anything in the world, make a table. But there's some other ways that you can do this. So let me show you a way that can help you if you remember what we've learned about exponential equations. So if we look at just this part of the equation, so never mind the plus 5 right now. Let's just look at this. Y equals 2 to the x power. What we know about exponential equations, that is exactly the same thing as y equals 1 times 2 to the x, because multiplying by 1 doesn't do anything. So the reason why we write it like that is because then we know this is our initial value. This is the growth factor, so it's doubling every time. So if I know that about the equation, I can graph that. So if I come over here and I say, well, it's going to start at 1, and then it's going to double. So double it, it's 2. Double that, it's 4. Double that, it's 8. Double that, it's 16. Double that, it's 32. Double that, it's 64. And so if I know that, I don't have to make a table because I can use that information to graph that equation. Okay, so that's how I graph that first part. Now the equation originally had a plus 5 on there, so what does that do? Well, what it does is it takes everything in this equation and it moves it up 5. Moves it up, everything is moved up 5. Every point is going to move up 5. So instead of starting at 1, it's going to start at 6. And instead of going to 2 after that, it's going to add 5 to that, so it's going to be at 7. And instead of being at 4, like it was right there, it's going to be at 9. And then we're going to keep going up. So instead of being at 8, that's going to be at 13. Okay, so we're just going to go up like that. So everything is going up 5. So what I have in red right there, that is going to be my graph for this equation. Now, if you needed to, you can certainly make a table. So if we say, okay, let's go for 0, 1, 2, 3, 4, and 5 for my x values, because that's what I'm going to do right there first. I would say 2 to the 0 power plus 5. So that means 1, because 2 to the 0 power is 1, plus 5 is 6. 2 to the first power plus 5. So that's going to be 7. 2 to the second power plus 5. That's 4 plus 5 is 9. 2 to the third power is 8, plus 5 is 13. 2 to the fourth power is 16, plus 5 is 21. And so you can keep going. And so you certainly can make a table. But I wanted to show you this so that in case you remembered what we know about our exponential equations, this just means it's going to lift up 5. Everything's going up 5 units. Okay, let's try the same thing with number 4. So number 4, if you look at just this part of the equation, so never mind that right now, that's the same thing as saying y equals 1 times 0.5, or we've seen it often like that, to the x power, so that's half-life. So if we start at 1, and then I go half of that, half of 1 is 0.5, and half of that is 0.25, and half of that is 0.125, and then half and half, and you can keep doing that like on your calculator, just divide by 2 or multiply by 1/2, and you get those numbers. So that's what that graph looks like. Okay, so then if we put the -1 on there, what's going to happen is everything's going to drop down 1 unit. Everything is going to drop down 1 unit. So all these parts, they're going to drop down 1 unit. And so let me go and erase this part of it. So what I would do then is I would say, well, I'm going to start there, and instead of being at 0.5 right there, I'm going to be at negative 0.5. And instead of being at, that should be at 0.25. Instead of being at 0.25, I'm going to go down 1, so it's at 0.75. So like this. So it's going to be looking like that. And so that's how I can do that. So the red part, that's going to be my final picture of the graph. Okay, so after this we've got some words that we need to go through and just understand what these ideas mean. So highlight or underline some important things. If we have 2 or more equations that are solved together, we call it a system of equations. So you've learned how to do that before. We are going to this year talk about 3 ways to solve a system of linear equations. 2 of them you've already learned before. So the graphing method, you learned this before. This is the least accurate method, but it's the best way to understand what's happening, so we always learn this first. The next method is substitution, and you've learned this before. And this is how we do solving systems without graphing it, so we don't have to draw pictures all the time and do graphs all the time, but we use our algebra skills to do that. The third way, and this one's a new one this year, is called elimination, so we're going to do that down the road, and so that's another really good way to solve systems of equations. The solution to a system, so when we're solving something we have a solution. The solution to a system of equations is the point or points that make both equations true. So I might have an ordered pair, like for example 2, 5, and that means that that ordered pair, if I plug it in for x and plug it in for y, it's going to make a true statement. A system of linear equations can have one solution. So like if you have 2 lines that intersect in one place, no solution would be 2 lines that never intersect. Or you can have an infinite number of solutions, and that's where you have one line and then you graph the other equation and it turns out to be the same line. Then they intersect at all these points, and we can't possibly write all of them, so we say infinite number of solutions. So instead of having to write the millions and millions of solutions, you only have to write 4 words, infinite number of solutions. The solution to systems can be written as an ordered pair, and that's how I want you to write them. And that is, again, where the lines are going to cross. Now, one thing we're going to be doing also is we're going to be talking about exponential graphs intersecting with linear graphs. So you might have more than one solution. And so that would be where the curve and the line crosses. If the resulting solution, when you're doing an algebra, when you're plugging in the numbers, like if you have an ordered pair like 2, 5, and you plug it in, if what you get is a true statement, like 9 equals 9, then what that means for us in a system of equations is it means that there's an infinite number of solutions. So before, when we just had one equation and we got a true statement, that meant all real numbers. But an infinite number of solutions is different, because if we're talking about one line and then we're talking about another line being exactly the same thing, there's all these solutions, and they're all solutions, infinite number, but you don't say all real numbers. So we're not going to say all real numbers, because if you say all real numbers, you're saying that this is a solution, and this is a solution, and this one, and this one, and this one. And those are not solutions because they're not on the lines. So that's why we cannot say all real numbers. So we say an infinite number of solutions. And that just means that there's an infinite number of points that the equations have in common. If the result is an untrue statement, so if you get something like this, then the system has no solutions. And that's the same as when we just did one equation by itself and we got an untrue statement and we said no solution. But this one, if we're doing a system, it means we have two equations that when we graph them or parallel lines, they're never going to cross. And so we say no solution for that. And so we would just write the words no solution. Okay, so you need to write that out. We're not going to be using that for this situation. We're not going to be using that for this situation. We're going to be writing out the words no solution. Okay, you're going to check your answer to a system. Okay, so when you have a system, you're going to check your answer by substituting the x and the y values back into the original equations. If the answer is correct or true, then that means that the equations are going to have true statements. That means that your solution is correct. Okay, so number 5, we're going to solve each system of equations by graphing and write our answer as an ordered pair. So the first equation is y equals 1/2 x plus 1. So graphing that, we're going to start at 1, and our slope is going to be 1/2. So up 1 and over 2, up 1 over 2. And so just keep doing that, and then you're going to get your straight edge and you're going to connect the dots. So this is just, just doing one equation at a time. That's what we've done before. We've done one equation. Okay, the second equation is y equals -3/2 x plus 9. So that one, we're going to start at 9, and our slope is -3/2. So I'm going to go down 3 and over 2, and down 3 and over 2. And what I'm looking for is I'm looking for where I hit the same point with both equations. So do you see that? Do you see where I'm hitting both of them? So it's right there. So that ordered pair, the location of that is going to be 4, 3, because to get there I go, starting at the origin, I go over 1, 2, 3, 4. So you have to name your x coordinate first, and then 1, 2, 3, so then your y coordinate. And so that's going to be our solution to the system. Okay, that also means that if I take 4, I probably shouldn't have erased all of that. If I take 4 for my x and 3 for my y, and I plug it into this equation, it's going to be true. And if I plug it into this equation, it's going to be true. That's what we're finding. Okay, for number 6, the first equation is y equals 4x minus 4. And the second equation is y equals 2 to the x power. So the first one is linear because it's y equals mx plus b form. So I'm going to start at -4. My slope is 4, so that's 4 over 1. So I'm going to go up 4 over 1, up 4 over 1, and I can keep doing that. So connecting those points, there's my one line. Okay, now my second equation, this is exponential. So remember what we've done before, and we've talked a lot about exponential equations. This is the same thing as 1 times 2 to the x power. So that means that my initial value is at 1, and it's going to double. So if I start at 1 and I double that, I'll be at 2. And then if I double it again, I'm going to be at 4. And if I double it again, I'm going to be at 8. And if I double it again, I'll be at 16. So when I graph this equation, it's going to look like that. Now, if you need to make a table for this, that's fine. You can do that. Okay, you put in, 0, 1, 2, 3, 4, and so on. And then you would type in your calculator, 2 to the 0 power, it's 1. 2 to the first power is 2. 2 to the second power is 4, and so on. So then you could graph those points. So 0, 1, 1, 2, 2, 4, 3, 8. So you can do that. But it's a little bit faster if you understand like what those numbers all mean, and since we've spent so much time, I would hope that you know how to do that, and you understand, and with practice that will help make that easier to do. So what I'm looking for, remember, is I'm looking for where do these two graphs intersect, what do they have in common. So if you see, I've got that point in common and this point in common, so I'm going to name those. Those points are 2, 4, and 3, 8. And so those are my solutions. I have two solutions to this system, and that's what they are. This is the end of part 1 of the lesson. So watch the second part of the video, and that will cover the last couple questions.